Today, the universe is a vast, cold void where structured galaxies drift billions of light years apart. Yet 13.8 billion years ago, that entire structure was non-existent. In the 1920s, astronomer Georges Lemaire proposed a radical idea that everything we see today was once compressed into a single, unimaginably hot and dense point he called the primeval atom. At this starting point, the heat was so intense that physical matter could not exist. The four fundamental forces of nature, gravity, electromagnetism, and the strong and weak nuclear forces, were melted together into a single chaotic superforce. To get from that boiling soup of pure energy to a universe capable of hosting stars, planets, and life, the cosmos faced a massive physical hurdle. It had to cool down. It achieved this through cosmic expansion, driven early on by a rapid burst of inflation. As this grid expands, the gauge shows how the temperature drops. When space stretches, the energy within it is forced to spread out over a much larger volume. As that energy dilutes, the temperature plummets. The entire physical history of the early universe is a chronological descent down a cosmic thermometer. As the temperature drops, distinct physical changes are triggered, step by step. The first major milestone happens in a tiny fraction of a second. Rapid inflation causes the temperature to drop by a factor of trillions. On this early timeline, we see the superforce shatter. Gravity and the strong nuclear force split off first, setting the universe's physical rules. Down at 10 to the negative 6 seconds, mass and energy stop being fluid. Energy solidifies, and tiny quarks freeze out of the plasma. When the temperature reaches a few billion degrees, quarks can no longer roam freely. They are bound together by particles called gluons, forging the very first protons and neutrons. But there is a catch. It is still entirely too hot for free-floating electrons to slow down and attach to these new protons. Because of this, the universe remains trapped as a blinding, opaque fog of charged plasma, where light cannot travel without instantly colliding with an electron. It takes another 380,000 years of expansion to reach the next critical temperature threshold, a moment known as the epoch of recombination. The universe has now cooled to roughly 3,000 degrees. Those darting, negatively charged electrons finally slow down enough to be captured by positively charged nuclei, forming stable, neutral atoms of hydrogen and helium. With the free electrons neatly packaged into atoms, the obstacles disappear. The opaque plasma fog clears, and space becomes transparent. This map of the cosmic microwave background shows the result. It captures the very first unhindered light racing across space, light that has been stretched into microwaves over billions of years and is still detectable today. This temperature milestone marked a physical boundary in cosmic history. The opaque plasma vanished, leaving a transparent void filled with the foundational units of matter. This brings us to a phase known as the Cosmic Dark Ages. The universe is a cool, transparent expanse filled with invisible dark matter and silent clouds of neutral gas. In this calm era, gravity takes over as the dominant actor. It pulls on tiny density variations within the dark matter and hydrogen clouds, dragging the loose gas together into massive clumps. As millions of tons of gas collapse inward, packing tighter and tighter together, the friction between the particles skyrockets. The centers of these clouds begin to heat back up. While the universe as a whole continues to expand and cool, these localized pockets reverse the trend. The pressure and temperature at the core reach tens of millions of degrees, high enough to slam hydrogen atoms together and ignite nuclear fusion. The Dark Ages end with the ignition of the very first stars. In the end, the entire universe had to undergo an epic cooldown to forge the raw materials of matter, only for gravity to compress and reheat those materials locally, lighting up the cosmos with its very first stars.